Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2019, Paper 2, Mathematics, and the question for this video is this. Suppose determinant of this matrix, which has some summations as its elements, is equal to 0, holds for some positive integer n. Then sigma k equal to 0 to n, nck by k plus 1 equals. It is a numeric type question. Let's solve it. If you see carefully, the first term essentially is sum of first n natural numbers, which will be n plus 1 by 2. If you see second row, second column element, sigma k equal to 0 to n, nck 3 to the power k, this essentially is 4 to the power n. Now you may say, how's that? It's because you may see this expression as nc naught 3 to the power 0 plus nc1 times 3 to the power 1 plus nc2 times 3 to the power 2 plus so on and so forth plus ncn times 3 to the power n. This essentially is binomial expansion if I have the expression 1 plus 3 whole to the power n. So this essentially becomes 4 to the power n. Next, let's consider row 2 column 1 element. Sigma k equal to 0 to n, nck times k. This essentially becomes n times 2 to the power n minus 1. And similarly, row 1 column 2 element, it essentially becomes n times 2 to the power n minus 1 plus n minus 1 times 2 to the power n minus 2. So how have these two elements come? Let's explore in the next slide. So sigma k equal to 0 to n nck times k. So here you may avoid 0 because anyway it will give you value 0. So we may take the summation from k equal to 1 to n. Now nck is essentially n factorial divided by n minus k factorial, but then when multiplied by k, I can write this as k minus 1 factorial. So if you see carefully, this essentially becomes n I can take out and it becomes n minus 1 factorial divided by n minus k factorial, k minus 1 factorial, k varying from 1 to n. So basically it is n times sigma n minus 1 c k minus 1, where k is varying from 1 to n. So it's essentially n minus 1 c naught plus n minus 1 c1 plus so on and so forth n minus 1 c n minus 1. So this essentially becomes n times 2 to the power n minus 1. Now if you see this another term, sigma k equal to 0 to n nck k square, again you may remove k equal to 0. You can start from k equal to 1 by, because when you put k to be 0 anyway the term would be 0. So k equal to 1 summation till n nck, this k square we may write as k square minus k plus k. So k square minus k I can write as k times k minus 1 plus k. Now if you see carefully, this essentially becomes sigma nck k minus 1 plus sigma nck k. Now here I can start k from not just 1 but 2. Why? Because when you put k to be 1, anyway this term would become 0, and for k equal to 0 it anyway was 0. So originally we started with k equal to 1, but for this particular expression we may start with k equal to 2 to n, and this is k equal to 1 to n. Now this we have just now evaluated above, and this turns out to be n times 2 to the power n minus 1. And what about this? This again, by the similar trick we may do it like this. I can write sigma n factorial divided by n minus k factorial, and k factorial would come, but when k factorial, when cancelled against k minus 1 which is coming in numerator, it essentially becomes k minus 2 factorial. So basically as k varies from 2 to n, I can take n minus 1 common from numerator and it becomes sigma n minus 1 n minus 2 factorial divided by n minus k factorial k minus 2 factorial. So this essentially becomes, as k varies from 2 to n times n minus 1 sigma n minus 2 c k minus 2, as k varies from 2 to n. So very simply this becomes n minus 1 times 2 to the power n minus 2. Why? Because sigma k equal to 2 to n minus 2 c k minus 2 would be 2 to the power n minus 2. So let's get back to that determinant, and this determinant essentially is 0. So let's expand it. So here, if I take 4 to the power n common, I would get n minus 1 by 2, and mind you 4 to the power n is 2 to the power 2n. So as you expand this determinant, after taking 4 to the power n common, you would get n minus 1 by 2 minus n square by 4 minus n minus 1 by 8 equal to 0. Now if you see carefully, 4 to the power n would never be 0. Even n equal to 0 we would not allow, because n is supposed to be some positive integer. So as you take LCM, now you get a quadratic, which would essentially be, actually there would be n square coming here, and when you cancel n, 1n remains. So as I was saying, you would get a quadratic which would be n square minus 3n minus 4 equal to 0. So that would mean n is either minus 1 or 4. But you not take n to be minus 1, because n is supposed to be, of course, some positive integer. So you take n to be 4. Now having got n to be 4, let's evaluate this expression. So here it becomes sigma k equal to 0 to 4ck by k plus 1. Now we can write this as sigma k equal to 0 to 4 factorial divided by k factorial 4 minus k factorial whole divided by k plus 1. So this essentially becomes sigma k equal to 0 to 4 factorial divided by k plus 1 factorial 4 minus k factorial. So this essentially becomes sigma 5 factorial divided by k plus 1 factorial 4 minus k factorial, and since I have written 5 factorial instead of 4 factorial, I'll also divide by 5. And the purpose of doing this is that we observe in denominator k plus 1 plus 4 minus k is 5. So to take this as 5 factorial, it enables us to write this expression as 5c k plus 1. So here this essentially becomes 1 by 5 times, you may say 5c1 when you put k to be 0, plus 5c2 plus 5c3 plus 5c4 plus 5c5. Clearly this is essentially 2 to the power 5, except the fact that 5c naught term is missing, so you will subtract 5c naught, which is essentially 1. So this essentially becomes 32 minus 1, which is 31, and 31 by 5 is essentially 6.2. That's our answer. Thanks for listening. Stay tuned for the next question.